Today's lesson, we will be looking at algebraic expressions. So at the beginning of the unit, we looked at numeric expressions, and now we're moving on to algebraic expressions. First, we're just going to highlight some key vocabulary terms, and I went ahead and kind of color coordinated. So these are just all vocabulary terms that you should be familiar with, as well as kind of grouping the terms together based on their topic and how they go together. So feel free to pause the video here and to kind of highlight. You can star things that you don't know, just so that you have them for studying purposes. All right, now we're going to go ahead and jump into the topics, and I really want to come in and highlight a couple phrases. So the phrase is more than, less than, and subtracted from. Those three phrases will be the most missed on any sort of assessment that we do when they're used, because on these three, you do not write things down in the order that you see them. So on everything else, whatever you see first is what you write first, except on more than, less than, and subtracted from. And on these three, you have to switch the order. Now, if you forget to switch the order on more than, you will be safe, because 2 plus 3 and 3 plus 2 get you the same simplified constant value. However, if you forget to switch the order on subtraction, so the less than and the subtracted from, you will end up getting incorrect answers. So I just wanted to highlight those three phrases for you. Kind of make note of those. All right, so first we're going to go ahead and translate. So I see the phrase less than, and I see the phrase product. So now I know that less than means to subtract. I know that product means to multiply. However, less than is one of those turnaround words. So even though A comes first, I'm actually going to put a minus A at the end. And then it says the product of C and D. And when we're doing algebraic expressions to show multiplication, you just write the two letters next to each other. You do not need to do any sort of a symbol. Everyone knows CD means C times D. Okay, so now we're going to evaluate. And for evaluate, we're just going to go ahead and everywhere that there's a variable, we are going to replace it with parentheses. And so now we're going to plug in, and it's when you plug it in, put parentheses. That's a phrase you should have gone over last year. So for C, I'm going to plug in a -4. For D, I'm going to plug in a 2. And for A, I'm going to plug in a -10. And now we're just back to order of operations. -4 times 2 is -8, minus a -10. Keep, change. I end up getting a simplified evaluated answer of 2. Okay, we are going to do the same sort of thing over here. First, we've got more than, which does mean to add. It is also one of those turnaround words. And then we have the phrase minus, which means to subtract. And we have the phrase squared, which just means an exponent. Okay, so we're going to go ahead and translate. So x squared is now going to come first. Then it's going to say more than, so plus y. And then at the very end, we'll put our minus z. All right, so we have translated that. So now it's time to plug and chug for evaluate. So everywhere there's a variable, we are placing parentheses. I am going to plug in the -4. I'm going to plug in a +9. I am going to plug in a -12. -4 times -4, so now it's time for our order of operations. Start with the exponent. I get 16 plus 9 minus a -12. 16 plus 9 is 25 minus a 12, keep, change. 25 plus 12 is 37 as my simplified answer. All right, next up, we've got our properties. So some of these properties we'll highlight should be review. So the commutative property just says we can change the order on addition and multiplication and you still get the same answer. The associative property just says we can change how they're grouped, not changing the order, just changing where the grouping is on addition and multiplication, and we'll get the same answer. The multiplication property of 0 is one you should know already. Anything times 0 is 0. You just maybe didn't know it had a name. And then the distributive property just says that when you have something on the outside of the parentheses, you are going to go ahead and distribute it to everything on the inside of the parentheses. And when you distribute it is a multiplication problem. And you have seen that Mrs. Stroll has drawn some hearts around the distributive property. It is by far my favorite property. And most importantly, the distributive property is going to be a foundational property for Algebra 1, meaning we will use the distributive property for the majority of the Algebra 1 topics. So that is definitely one to know. Okay, identity property. Your identity is who you are. That's how I kind of tell kids how to think of it. So if I am Mrs. Stroll, I don't want to change from being Mrs. Stroll. I want to stay Mrs. Stroll. If you were to represent Mrs. Stroll as a number, my favorite number is 10, so I would want to be the number 10. I would want to keep my identity. And the only way to keep my identity would be to add nothing to myself. So 10 plus 0 would allow me to stay the number 10. So that is the identity property of addition. Any number plus 0 will allow the number to keep its identity. And then the same holds true on multiplication, but we're not going to be looking at 0. In order for 10 to stay 10, we would have to multiply by 1. And so that's the identity property of multiplication. And the other property are called the inverse properties. And I want to send you back to that vocab list here. So additive inverse was just a fancy way of saying opposites, 10 and negative 10. And multiplicative inverse was a fancy way of saying reciprocal, 2/3, 3/2. So reciprocal and opposite are words you should already know, but additive inverse and multiplicative inverse are the algebra versions to describe those two. And when you think of that, this property now makes a whole lot more sense. The inverse property of addition simply says when you take a number and you add its opposite, you'll always get 0. And the inverse property of multiplication says anytime you multiply reciprocals, they will always turn into the number 1. So those are our new properties for Algebra 1 that we have not covered before this class. So let's just go ahead and practice identifying these properties. So the first property says n plus 0 stays in. Well, that is just going to be the identity, and you can abbreviate identity as ID. And then it's the property of addition. And you do need to specify of addition or of multiplication. Okay, the next one, I'm the letter A. I get distributed. So this is a review property. This is the distributive property. All right, the next one says the opposite of n and a plain old n equals 0. So that would be the inverse, and we can abbreviate that, property. And this is again of addition. And then I'm the letter N, I multiply by 1, I stay the letter N. So that's another identity, except this time it's the identity property of, and we can use the X for multiplication, the times sign. Okay, now we're going to go ahead and use these properties in order to simplify some algebraic expressions. So the first thing we're going to do is we're going to distribute that negative 3. So now I have negative 12 minus 6x. And then I have my 5x. And now we're going to go through and combine like terms. You probably saw this as the box and circle method when you very first learned how to do it. And the trick is they have to be like terms, so they have to be the same variable. raised to the same power. So a 5x and a negative 6x just turns into negative 1x, but remember you don't need to write the 1, it's invisible. And then we're going to have our minus 12. And those are not like terms, so now it's simplified. All right, we're going to do that again. First thing we're going to do is we're going to go ahead and distribute. Half of 8x is 4x. Half of 12y is 6y. Then we're going to do negative 3/4 times 8. Well, 4 goes into 8 2 times. 3 times 2 would be negative 6x. And then negative 3/4 times negative 12. 4 goes into 12 3 times. 3 times 3 would be 9y. And now we're going to come through and combine like terms. So my two terms that have an x are like terms, and my two terms that have a y are like terms. And so a 4x and a negative 6x will add up to negative 2x, and a negative 6y and a positive 9y will add up to positive 3y. And that is my simplified algebraic expression. All right, now we're going to go through what is called an algebraic proof. So an algebraic proof is where they've already done all the steps for you. You just have to mathematically prove that what they did was legal. And how you can prove that is by using properties or definitions. So I always do a proof by starting with the top line. That will always be your given problem. And then you read it top down. So going from here to here, you just ask yourself, what did they do? And hopefully you're going, oh, well, they used the distributive property. And that would be absolutely correct. That's how they got this line, by using the distributive property. So now you're going to say, okay, going from here to here, what did they do? And you're going to just simply go, oh, they just simplified. Or you could say they multiplied, but I'm going to do simplify. But again, if you wrote multiply, that's fine as well. Okay, now you're going to say, okay, well, going from here to here, what did they do? The only thing I notice is they changed a minus sign to adding the opposite. And that is technically the definition of subtraction. By definition, subtraction is to add the opposite. Now, why did I do that? Well, because all of my properties, if you look over on the left-hand side, all of my properties are either properties of addition or properties of multiplication. None of them are properties of subtraction. So I needed to get it into an addition problem. Okay, now that I have said that was a legal move, I'm going to go from here to here, and I'm going to say, okay, what did they do? And I noticed that right here, all they did was change the order. And the order, or the property that says we can change order, is the commutative property of addition. Then I'm going to look, and I'm back from here to here, and I'm going to say, okay, what did they do? And I noticed they just said 2x and 3x turns into 5x. So that, again, you can say simplify. You could also say combine like terms if you wanted to be more specific. But simplify is perfectly fine for these. All right, so then I'm going to say, okay, well, what did they do from here to here? And I'm going to quickly notice they just said that when you add opposites together, it'll turn into 0. And that is the property, inverse property of addition. And then last but not least, going from here to here, all they did was say when you add 0, it stays the same, and that is the identity property of addition. Okay, so that is an example of an algebraic proof. We will practice proofs in units 1 and 2, and then proofs are a very, very big part of your geometry class that you take after Algebra 1. So this year, our job is just to introduce you to the idea of a proof and understanding that we can show mathematically that steps are legal by citing either properties or definitions. And so we're going to practice that, but then the main focus of proofs will be in your geometry class. And last but not least, you are in junior high, and so you will be asked to take standardized tests over 7th and 8th grade standards. And 7th and 8th grade standards have a lot of pre-algebra, so a lot of the foundational stuff for the algebra class you're in right now. So we will cover that and go beyond. But the one thing that shows up in junior high standards that does not show up in Algebra 1 are geometry concepts, because there's a standalone high school geometry class for that. And so to help you review those geometry concepts, I always like to try to sneak in geometry connections in the algebra units anywhere I can. And so this is that, me sneaking in some junior high level geometry review in a lesson that we're looking at algebra. So I've given you a picture of a trapezoid, and I am asking you to find the perimeter. So knowing that this is a trapezoid and knowing that perimeter means to add up all the sides around the outside, those are junior high geometry concepts. Now, we're extending it into the algebra classroom because in order to find the perimeter, we're really just simplifying an algebraic expression. So I am coming around this shape, and I am just going to look for like terms. So B, 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 and 2B are all like terms. So I can add all those together. B plus B plus B plus 2B would be 5B. And then I'm going to come around and I'm going to add up all the constants. So I've got a positive 1 and a positive 3, so that gets me to 4. Then I'm going to subtract 1, and that gets me to 3. And then those are not like terms, so that would be the simplified algebraic expression that represents the perimeter of this trapezoid. And that is the end of today's lesson over algebraic expressions.